I can unlock it. Yeah.
So we're here at Neonode here at Mobile World Congress. So this is a Neonode, which is what is that? The latest version, or?
No, this is actually an old phone from 2007.
And so you're famous for doing the iPhone before the iPhone, no? Kind of.
I wouldn't say that. We developed a very nice and innovative touchscreen phone that used a lot of sweep gestures, as you can see.
So your gestures were in the phone since 2005?
Yeah, 2004.
2004.
We had a gesture-based phone that did a lot of these sweeps that you can see.
The size of the screen?
This is a 2-inch screen.
2-inch screen.
The idea of this phone was to have something nice, convenient, that you can fit in one hand and operate with only your thumb using gestures.
And so now the company is focusing on licensing the screen technology, right?
That's correct. So we've gotten out of the phone business for now. We're more focused on touch solutions for other products. This is an idea of a demo. We can do proximity sensing. You can see the things happening on the screen based on my proximity to the different areas of the... We can also sense the position of a finger, of course, and the power, the pressure that I'm applying. So more pressure. So it's not only a touch sensor, but it's also a pressure sensor and a proximity sensor.
That's amazing. Like, all these capacitive screens don't do any of that, right?
Today they do not.
They don't do proximity, they don't do pressure, do they?
No, they don't.
You cannot measure the difference in how much you push over there.
Right.
But there you can totally do it?
We do that. In addition, we released a controller chip with Texas Instruments, who developed it together with us. And it's really a wonderful breakthrough because it allows you to do a scan rate of about 1,000 hertz. So at that rate, you get a very, very high fidelity, close to where the touch is. So we can do stylus touch, and it's really the feel of writing on paper. You don't find that in any other touch technology.
1,000 hertz, and what was your previous hertz?
2050.
2050. That's what's on the market right now.
Yeah.
So it's going to be increased by 50 times.
Yeah.
So, so you see your touchscreen technology on e-ink readers, right?
Yes.
For example, Sony.
Yeah, we're in the Sony e-reader. That's right.
I heard it was IR touch.
That's correct.
Infrared. Is that what you do?
That's what we do. So we have, it's an infrared grid that we project over the screen. Or in the case of Sony's latest products, it's not even a grid; it's a whole sheet of infrared light, and that allows us very high precision when you place anything on the screen. You block a portion of the light, and we can detect what you're blocking, how much you're blocking, and we can get very high precision for that. So even a stylus, you don't have to have a finger, you can do a stylus.
But you call that IR touch, or is it
infrared?
Optical?
Well, it uses light, it uses infrared light.
Yeah.
So it is an IR touch solution. Light is optical, so I guess you could also refer to it as an optical solution. But it's not, we're not capturing an image of the screen. It's a very low-cost solution that uses only the LEDs and photodiodes around the screen.
But when you had this device, it wasn't doing the same thing, right?
Yes, it was.
It was actually IR here.
Actually, yeah. If we took apart this phone, you would see a row of LEDs along the top and left side, and a row of photodiodes along the bottom and the right side, and the LEDs projected light across. That was detected by the photodiodes, and a press of the finger blocked that.
And is that also what's going on over here?
Yes, but you can see, for example, the difference in the height of the bezel. Here we've got about 2 millimeters on a 2-inch screen, and here we're down to about a 0.5 millimeter.
0.5 millimeter,
and no height besides that. In other words, there's no. The thickness of the screen is only that 0.5 millimeter of the bezel that has to be increased. Everything else can lay flat on the PCB of the manufactured device.
So all that stuff about pressure sensing and
it's all included in
proximity,
this one. That's all based on an LED.
But that's new, or you've always kind of been able to do that?
Well, we've always been able to, but we haven't. In this phone, we didn't do that. It's something new that we're offering to our customers.
And the e-readers, they're not doing that.
Not yet.
Is this a software issue, or basically you are sensing it, you're just not taking...
Right.
All right, so how can you do pressure with that?
Well, basically, what happens when you press on the screen is, even if it's a very rigid screen, there's still some flex on the screen. The screen does move, or it gets flexed in a certain way, and that'll increase the level of the light that enters through the bezel. So you actually, normally your touch is detected by a blocking of the light, and in this case we can detect it. We can detect increased pressure when the surrounding LEDs sense an increase in light.
Nice. So there's a lot of talk, and since the iPhone came out, about capacitive screens and lots of capacitive screens. Do you envision your technology taking over capacitive?
Well, we think our solution has very compelling advantages in a lot of cases. For example, in the e-reader market, we had a clear advantage that there was nothing over the screen, and that's important for an e-ink screen. In a lot of other cases, especially with large screens, we have a very strong economic advantage because the cost of a screen, let's say a screen like this, a capacitive screen is going to have to develop something as large as this screen. That's a $100 investment. In our case, we're talking about LEDs and PDs that surround the screen. So it's an order of magnitude lower cost. It's very high performance. So it has a lot of advantages. You'll never be the only solution in the market, but we think that there's a justification for us in the market.
There's a lot of touchscreen technologies, right?
Yes.
Like 5,000 or something.
Well, I don't know how
there's
that
lots.
many, but there's a lot for sure.
And your market is growing how fast? Can you say anything about how many are you selling of these?
We can't say numbers, but we're in a number of the ebook reader devices, and we're in a lot of designs for tablets and some phones. So you're going to see more and more of the IR touch being adopted in the industry.
I saw a prototype with a Pixel Chi screen. Renaissance, because Pixel Chi has a sunlight readable mode,
yes.
Even if it's LCD.
Right.
It's much better not to have all that stuff going on with the capacitive and resistive is even worse, I guess.
Right, so we're working with also with some resistive technology screens, and the advantage there is very compelling.
Instead of resistive, you mean, right? Not together with the resistive?
No, you have a reflective screen.
Yeah.
So in sunlight, the visibility is beautiful. And because we have an IR touch, there's nothing over the screen, so you get the full image coming through.
So your company is based in Sweden?
Yes.
And so are you doing R&D for the future? Like what's going on?
Absolutely.
What's going to happen in the future?
We're seeing a lot of exciting things, a lot more of this. Instead of just having a screen that has basically 2D touch or on-off touch, we're going to see something like this, which is a cavity, and you can tilt your finger within the cavity and detect where the finger is moving, and based on that have a lot more user interface options. So
why do you have a cavity? Because you have a lot of
exactly
layers?
We have a few layers in here of IR sheets, and therefore you can see how fast the finger is moving in. The demo's off now, but you can see angles of the finger. So there's a lot of room for really nice UI options.
You always need to have a little bezel, at least 0.5 millimeter on the side, right? That
at
above the screen.
At this point.
What do you mean? Like in the future, it'll be
it's
zero?
possible that we'll go down. We'll have other technologies that will be able to have something reflected inside the screen glass itself. But at this point, we're looking at a sheet of light over the screen. But like I said, I mean, even in this case where it's only a very thin sheet of light, we can still detect proximity, above the screen.
Right.
Like so. So we're not just on the screen.
And how about how responsive is it compared to capacitive, multi-touch and all that?
Extremely. I mean, like I said, with 1,000 hertz sampling rate, the response is instantaneous. It really feels like a finger, like a pen writing on paper.
You can totally do multi-touch.
Yes.
The fingers or a pen is fine. Both are fine.
Yes.
And precise.
Extremely.
All right. So basically, there's no reason to have capacitive anymore.
There's always a reason to have capacitive. You're never going to knock out another technology. It's a wonderful technology. It exists in the market, and it's serving a very important purpose. We think that there's room for additional technologies, and I think the market is going to find that there's more than one solution for touch, for sure.
So here's, would you call this the future of Neonode technology?
Yes, this is a way to interact with the device differently than before. You can move around in a room like this.
So when you would have this where? On top of the device, or?
You can have it on the side like this.
Like a mouse?
Yeah, like different sizes. So you can connect to a tablet on the side. So you can do things with this and on the screen at the same time.
With this and on the screen at the same time.
Yeah, so for example I could pick something on the screen and then I could change the direction of that. I could, for example, have something like this, I could grab to that and...
So you're basically doing that in the air.
Yeah, I could then move around.
Cool.
And you can see you can see also which side this is coming from. So you can see if it's coming from the back side or...
That's cool. So this is when did you finish this prototype?
It's actually just our touch, but we just put another layer on it. Yeah.
So
And then we add to that we add
pressure. Yeah.
pressure.
I already feel that.
Yeah, you try that. Okay.
Okay. Well, so how soon is this in the market? Like how soon the device is going to come with
Hopefully,
this?
our customers will license it.
But it's not going to be on phones, is it? Or is it for phones?
Phones, tablets,
So
gaming devices.
You would need a thing like this on the side, on top of a phone?
You can either put it like a frame, or you can put it on the side. So on top of the display or on the side.
But you need that much
No, you need only 2 mm thickness.
2 millimeter thickness to do all this?
Yes.
Oh, cool.